Welcome to our deep dive into how the browser renders or displays the content. Today, we're unraveling the mysteries of the critical rendering path, a vital concept for anyone keen on mastering web development. Let's get started. The critical rendering path is what happens between receiving HTML, CSS, and JavaScript bytes and turning them into rendered pixels on your screen. Think of it as the backbone of your web page's loading process. Inside the browser, this process involves several crucial steps: constructing the DOM, building the CSOM, creating the render tree, laying out the page, and finally, painting it on your screen. DOM construction is a fundamental process in web page rendering where the browser translates the received HTML document into a structure it can work with. Here's a deeper look into the process. Receiving HTML bytes. Initial step. The browser receives the raw bytes of the HTML file from the server. Character encoding. These bytes are interpreted into characters based on the specified character encoding, like UTF-8. Conversion to characters. Translation. Each byte is translated into a character that represents an HTML element, attribute, or text. Tokenizing. Breaking down. The stream of characters is broken down into distinct tokens. Tokens are the smallest units that have semantic meaning in HTML. For example, start tags like end tags like attribute names and values, etc. Syntax analysis. The browser checks these tokens against the syntax rules of HTML. Lexing, token classification. Each token is classified based on its type, like a start tag, end tag, or attribute. Creating objects. Tokens are then turned into objects that define their properties and rules. DOM tree construction. Tree building. These objects are linked in a tree-like structure that accurately represents the original HTML document structure. Hierarchy and relationships. The tree demonstrates the parent, child, and sibling relationships between elements. DOM nodes. Each HTML element becomes a DOM node in the tree. For instance, a tag would be a parent node to any elements within it. The CSS object model, CSSOM, building process is an essential part of rendering a web page. It's where the browser interprets and organizes the CSS cascading style sheets, instructions to define the visual presentation of HTML content. Let's delve deeper into the CSSOM building process. Receiving CSS bytes. Initial fetch. The browser first fetches the CSS files, which might be included inline within the HTML, linked externally, or imported within CSS. Byte interpretation. Similar to HTML, the raw bytes of the CSS files are interpreted based on the specified encoding, like UTF-8. Conversion to characters. Character mapping. These bytes are converted into characters, representing CSS properties, values, selectors, etc. Tokenizing CSS. Breaking down syntax. The CSS character stream is broken into meaningful tokens. These tokens represent CSS syntax elements like selectors, properties, and values. Syntax rules. The browser checks these tokens against CSS syntax rules. Creating nodes. From tokens to nodes. Each token is transformed into a node in the CSSOM. For instance, a CSS rule like div color, red, would result in a node representing the div selector and its styling properties. CSSOM, tree construction, building the tree. These nodes are then assembled into a tree structure, the CSSOM, that mirrors the structure of the CSS rules. Hierarchy and cascading. The tree respects the cascading and inheritance principles of CSS, where styles are applied in a hierarchical manner and can be overridden or inherited according to CSS specificity and cascading rules. Combining with DOM, interaction with DOM. The CSSOM is used in conjunction with the DOM to apply styles to the elements represented in the DOM. This combined structure is crucial for the next step in the rendering process, creating the render tree. Render tree formation, merging DOM and CSSOM. The render tree is formed by merging the DOM and CSSOM, which results in a tree that holds both the content from DOM and the style from CSSOM, information of the web page elements. Dynamic updates, reactivity to changes. The CSSOM can be dynamically updated, for example, by JavaScript, which in turn updates the presentation of the web page without needing to reload the entire page. The render tree and layout stage in web page rendering is a critical process where the browser combines the document object model, DOM, and the CSS object model, CSSOM, to form the render tree, which is then used to calculate the layout of each visible element on the page. Here's a detailed explanation of this process. Render tree construction, merging DOM and CSSOM. Combining structures. The render tree is created by merging the DOM, which represents the HTML structure of the page, and the CSSOM, which represents the CSS styles. Why both are needed? The DOM alone doesn't have style information, and the CSSOM alone doesn't have the content structure. The render tree combines both, creating the render tree, visible elements. The render tree only includes nodes that are required for rendering the page. It omits non-visual elements like script tags and elements set to display. None. Render objects. Each node in the render tree corresponds to a render object. Each render object contains the dimensions and position, along with the styling information from the CSLM. Layout process computing the layout, from render tree to layout. The layout process involves calculating the exact position and size of each render object. Box model. Each element is considered a box, with possible padding, borders, and margins, as defined by CSS. Flow of layout calculation, recursively through the tree. Starting at the root of the render tree, the browser calculates the layout for each node, determining where each element should appear on the screen. Viewport consideration. The calculations consider the viewport size and handle different screen sizes and orientations. Global and incremental layout. Initial full layout. The first full layout is calculated for the entire page when it's initially loaded. Incremental reflow. Subsequent changes, like an element size changing due to a JavaScript action, can trigger reflows, recalculating layout for part of the tree. Importance of render tree and layout. Critical for visual output. This step is crucial because it translates the code and styles into actual pixels on the screen. Performance consideration. Layout calculation can be complex and time-consuming, especially for large or complex layouts, making it a critical factor in web page performance. In summary, the render tree and layout process is where the abstract constructs of HTML and CSS are translated into concrete visual elements on the screen. This process determines how each element of the web page is sized and positioned, ultimately defining the user's visual experience of a web page. The role of JavaScript. JavaScript plays a tricky role. It can either block or enhance this process. For instance, when a browser hits a script tag, it may pause everything else. That's why understanding synchronous and asynchronous JavaScript is crucial. Optimizing the critical path. To optimize this path, analyze and minimize critical resources, optimize their sizes, and order their loading strategically. Every millisecond saved here enhances user experience significantly. Mastering the critical rendering path is key to lightning-fast web pages. Apply these insights and watch your website soar in performance. Don't forget to hit like, subscribe, and share your thoughts in the comments